Welcome back to the channel, and we're back in Juno New Origins trying to learn how to become rocket engineers and also astronauts. We're building and flying the rockets all at once. Now, in the last episode, I made some major breakthroughs and did some pretty hefty contracts, but there's a lack of contracts right now. But I noticed in the tech tree, if I actually unlock the ability to have multi-stage rockets, it actually gets me some new contracts, which probably involve using the multi-stage rockets. So I just happen to have exactly the right amount of tech points to unlock this thing. So let's do it. Let's get some new contracts and let's see how it's gonna be related to staging. All right, so now in my career, only 50K, really? I did a contract for 150K last time. Okay, so Drew's atmosphere ends right under 80 kilometers. That would have been really good to know the last episode. Can I go to space to expose a probe a scientist has sent me? What? This contract has a tutorial. Oh, another tutorial. Great, I get to actually learn instead of just guessing on what I'm doing. Okay, well, I guess let's learn how to do stages. Let's start with the same rocket we built for the vertical shot contract minus the nose cone. First, let's attach the payload. We're actually carrying a payload. This is what the customer wants us to bring to space. Oh, okay, so be careful with it and try not to damage it. All right, so we actually have a payload section in the build menu. This is a sounding rocket payload, a small experiment encapsulated in a simple fairing. So I bring that, attach it right there. All right, now let's add an interstage. Okay, here we go. It splits the rocket into multiple stages, but more on that later. All right, interstage. Use this to split your craft into stages. Kind of want to know what I just did before I start moving on to the next part. All right, now let's add another fuel tank below this, but we'll make it a bit fatter so it can hold more fuel. Is that how that works? Resize the fuel tank to match the desired size. Okay, there we go. There we go. All right, now we got to connect an engine. Looks like we're using the solid motor engine. Looks like it wants me to have 3 of them installed. Now let's add some fins to the bottom stage for more stabilization. We can clone the fins from the upper stage to save us some work. So we right click and drag to clone. And then just bring it right down there. Enable some symmetry. One last step before we call it a day. Let's look at the staging for this rocket finally. Now I need to actually learn what I did here. Staging just means the order that parts are activated. Stage 1 first, followed by stage 2. Your big engine should activate first and burn up their fuel. When they're empty, use interstages to jettison them to lighten the load for later stages. Click the pre-flight configuration. Oh, this is a new menu for me. This is new. Normally, it's calculated automatically, but it's a good idea to check it before launching. The second stage engine should actually be in stage 2 so it can activate and do its thing before its payload is deployed. All right, so for some reason, second stage engine was in the wrong one. I'm a little bit confused on why that was and how this stuff is automatically labeled. Excellent. I've built a multi-stage rocket. This looks like a really odd and awkward multi-stage rocket. I'm used to seeing the stages like next to the first or the second or third stage, not literally in line with them. Is that normal? Are there just rockets that I've never seen before like this? Probably, I don't know. Let's click the launch button and see how it flies. Is this all gonna happen automatically? Is it automatically programmed to detach the stage once it runs out of fuel? All right, press space to activate my first stage. Here we go. Leave the atmosphere with a payload. Oh, that's all I have to do? I just have to get out of the atmosphere? I've already kind of done that, I think. All right, so is this just the first stage? Wait for your first stage to run out of fuel. Okay, here we go. 0, press space to activate. I have to do it manually? Okay. Oh, wait until the rocket goes higher than 80 kilometers and then stage again to expose the probe. We need to get 80 kilometers. We're running out of fuel. We're only at 40 kilometers. We're halfway there, but we should be able to use our current velocity. We're going over 1,000 meters per second. So we're starting to slow down now because we no longer have, oh wait, do I have to press space now? Launch with the payload. Leave the atmosphere with a payload. What happened? I think I must have pressed space too soon. I thought I was supposed to press space when I ran out of fuel. I guess I was supposed to wait until I actually left the atmosphere, which I did just now. I'm at 80,000 now. Ah, okay. I just got impatient apparently. Well, let's retry that. All right, here we go again. We just gotta pretty much time lapse this. Let's get out of fuel, switch stages, get out of the atmosphere, and then figure out what happens at 80 kilometers. All right, first stage out of fuel. There we go. I actually want to see it fall this time. We're just leaving it behind there. All right, and fast forward again. I'll see you guys out of the atmosphere. This rocket's going out of this world. Okay, here we go. 75, 76, 77, 78, 79, 80. Expose the probe. There we go. The probe has been exposed. All right, I have 399,000 money. 0 tech points, apparently. I need to do some tech stuff. All right, light speed. What? Once you leave the atmosphere and you free yourself from its drag, there's nothing stopping you from going as fast as you want. Okay, so I need to leave the atmosphere and I have to go faster than 1 kilometer a second. I accept. So I'm gonna accept this one, and I'm also realizing that the fireworks quest that's just been sitting here, it basically tells me I need to explode my rocket. It has to have a certain amount of explosion though, which it probably won't if I'm going light speed. But I just have to explode it above 10 kilometers. So I might as well accept that, and if I happen to be above 10 kilometers with 3,100 boom power, then I can at least explode myself and complete that. But we need to, this is our big thing right now. We need to basically go faster than 1 kilometer a second. Once we escape Earth's atmosphere and gravity isn't gonna be having as much of an impact on us, we can just keep increasing our speed. All right, so let's go into the build mode. Let's see if we can modify this rocket. Wait, so if this is the interstage, can I make an interstage? Let me see if I can add an interstage sideways. How would I do that? All right, hold on. I'm gonna kind of start from scratch here. We have our initial rocket, or our final stage of the rocket here. This doesn't need to be a probe anymore. This can just be a standard nose cone. We'll delete that engine because I want to add this block on the bottom. Oh, I can't adjust the block. I thought these blocks were going to be scalable, but they're not, which makes it not good. Oh, what about a strut? Resizable strut that can help bolster your crafts. Ooh, can I resize this? Oh, here we go. Now with that strut, can I put an interstage? Dang. The stages be next to my primary stage. I just thought it would be a little bit more natural looking. All right, I guess I gotta do it. I gotta do it the way the game taught me. All right, I'm gonna make the size of this rocket engine for the final stage at 150% power. Gonna add my interstage. Detachment force. Percentage of maximum force to apply when detaching. So you can actually have stuff fly away from your vehicle pretty much. All right, well, let's see if I can create a 3-stage rocket. I think my maximum number of stages is 3 anyway. So this one's going to be a little bit thicker. I'll copy these fins just like it taught me. I'll make these engines slightly bigger on this one too for some more force, but that is not even gonna be, this is not even our final form. Now I'll add another interstage onto that one, and then a third what? And this one's gonna be even thicker. This is gonna be a weird rocket. Thicker and longer. All right. And then another set of fins. This time I will do radial 4. And then same thing with engines. So this is gonna be our strongest stage, which makes sense. All right, so now I think here is, why is this, does it say 5? Okay, there we go. Stage 1. Stage 2 is to detach stage 1. Then stage 3, you can see it highlighting the appropriate engines. Interesting. Then stage 4 is to detach stage 3. And then stage 5, did I create too many stages? I thought the stages were like the sections, but it's actually the steps of the process, I guess, including the ignition of the thrust. So this might actually be too many stages. So let's see if the game lets me launch. This craft has one or more issues. Yeah, aw, man, I wanted to create a 3-stage rocket, but this is actually a 5-stage rocket. It's also too tall. That's because of the stages. So let's just delete that. And I guess let's just make the first stage here have a little bit more fuel. Here we go, because we really need to get as close to space as we can before we use that final stage, because we need to be really far away from the gravitational effect of Earth, so that final stage can really just keep adding into our velocity and get to 1 kilometer a second. So let's actually do radial symmetry 4 then, for these engines, and then increase their power a little bit more. All right, what are we looking at for our stats over here. Burn time, 38 seconds. And then this one, oh, I guess is that total burn time for all stages? Only 38 seconds? Stage 1, 21 seconds. Stage 3, 17 seconds. All right, you know what, stage 3? You're getting a little bit wider. That's not a little bit, that's a lot. All right, you know, stage 3 going wider, and this stage going wider. We need a little bit longer burn time. I hope I'm not making myself too heavy here. We'll find out. All right, now stage 3 has 68 seconds of burn time, and stage 1 has only 47 seconds. That's because it has way more engines. Let's see how this one does. So far, anytime I deviate from the tutorial rocket ship, it tends to not go very well for me, but hey, let's see what happens. Here we go. First stage is active. Let's go ahead and increase our speed here. We need to get 80,000 kilometers above the surface, and then we need to try to reach 1 kilometer a second, I believe. All right, we did not get very high. I'm activating the second stage. Wait. Okay, there we go. I think I let myself lose too much velocity there. I was really hoping to get closer to the atmosphere transition before I went to my second stage, because now it's not looking good. I don't think it's looking good unless we get out of the atmosphere. I cannot turn the engine off either, because we need to be out of the atmosphere and keep inputting velocity into our craft. But I can't do that. I'm almost out of fuel and I'm still in the atmosphere. Our speed is 1,000 meters a second. Achieve a space speed record? Wait, oh, that's it, isn't it? I did it. That's 1 kilometer a second. Okay, that wasn't actually that hard. Well, unfortunately though, I don't think I have any boom power. Explosive power is 0. So exploding myself will not accomplish the other task, but I was just doing that just in case. So I wasn't expecting to succeed that time, but I did. So all right, good for us. We're rich. 486,000 now. So now, whoa, I have a new customer. 500,000 and 400,000. They want me to reach 2 kilometers a second or 2,000 meters a second, which I didn't even see what my max speed was that time. It was definitely over 1,000, but I don't know how close to 2 it was. Okay, Drew orbit, 500,000. Can I go to orbit? I need you to be close to specific orbits that I know you can get there first. Get to any orbit to prove yourself. All right, so this is my new customer. As much of a wacky scientist Pricklespack may be, that is such a name. Professor Von Pricklespack. He's one of the most renowned researchers on Drew. He's looking for some help to gather data to prove the presence of other forms of life in the Juno system. Okay. Well, might as well accept this one. We may get to 2 kilometers a second while we're trying to get to orbit. So let's start our orbit tutorial. Requirements. Periapsis, 80 kilometers. All right, well, that's a new word for me. Whoa! Whoa, why is the rocket black? This looks so cool. This coloring is so cool. What are these things? We have a craft ready for you to use, but it needs a few tweaks to its engines to improve its performance so that it can achieve orbit. This is so cool. This is the craft's total delta V, which means change in velocity. Theoretically, this is how fast the craft could go in a perfect environment without gravity and without drag. So we could go 5.42 kilometers a second. All right, so basically, if we started this in space, we would get up to, I think that means we'll get up to this speed. Realistically, we need at least 4,500 meters a second to get into low orbit around Drew. That's a lot. It appears that we have more than enough. Okay. But we also need to consider that engine performance is affected by atmospheric pressure, which changes with altitude. Ooh, this is getting complex. Altitude. Ooh, look at that. If we're at ground level, our delta V is only 870 meters a second. Curse you, atmosphere. We have some work to do. We'll need to look at each stage and see what we can do to improve performance. Don't worry, it's just rocket science. Haha. I have about 3 videos of experience in rocket science. Let's look at the first stage, which consists of 5 solid rocket motors. Ooh, I like this. So it gives you the delta V of the individual stages, so you can assume that you're going to be closer to ground at this stage. You're going to be higher up at that stage. So then if you knew the math, you could calculate how high the delta V would get you in the first stage, and then change the the altimeter here to where your second stage is gonna start, and then go to stage 2. Interesting. All right, let's see what it's actually telling me though. Delta V looks okay for this stage since we just want to use it to gain some altitude before starting the more efficient engines. What makes them more efficient? They require a thinner atmosphere to work. Okay. Another important metric is the TWR, which stands for thrust to weight ratio. Oh! Okay. If this is less than 1, then the craft will not be able to overcome gravity during liftoff. I was looking for that a couple episodes ago. If only I knew what TWR meant back then. And one last thing is the ISP, which stands for specific impulse. And why isn't it the SPI? Someone messed up on this acronym. Ooh, it's the new type of engine. Let's look at the second stage. From our previous launches, we found that this stage will ignite around 8 kilometers. All right, so let's go up to 8 kilometers. Around 8 kilometers, close enough. All right, the Delta V and starting thrust to weight ratio is terrible for this stage, so only 700 meters a second. Ooh, look at that thrust to weight ratio. This is because the Gnome engine is optimized to work in a vacuum, but don't worry, we can do some rocket surgery here and improve its performance inside an atmosphere. All right, I'm ready for some rocket surgery. Remember when they performed surgery on a grape? I'm about to perform surgery on a rocket engine. Man, this is getting really, all of a sudden, it's just like, here's what all of this means. You've been looking at this with no knowledge, and now we're just exposing you to all of it at once. This engine is suffering from a severe overexpansion, which happens when the engine's exhaust exit pressure is less than the air pressure. Man, I'm learning so much right now. Overexpansion is what causes shock diamonds. What? I've never heard of shock diamonds before. Overexpansion causes shock diamonds to show up in the exhaust. All right, I have to look it up. I have to look up shock diamond. I gotta see this. Shock diamonds are the bright areas seen in the exhaust of the statically mounted engine. Whoa, oh, those are cool looking. Standing wave patterns. Oh, okay. They're actually a complex flow field made visible by abrupt changes in local density and pressure as the exhaust passes through a series of shockwaves and expansion fans. All right, anyway, enough learning for now. We got other learning to do. All right, the closer exit pressure is to air pressure, the more efficient the engine becomes. So the exit pressure is way too low right now. We can shorten the nozzle and crank up the power to increase this exit pressure so it's closer to the air pressure. Okay, properties. Nozzle throat size. So this, if I look over to the right side, exit pressure is now increasing, but not by enough. Nozzle length. Oh, we need to make it less. There we go. So we want it to be close to the same amount. Change the nozzle length to 50%. All right, well at 50%, it's a little bit lower. Oh, and then I can change the size of the engine too. We can shorten the nozzle, crank up the power. Change the size to 81%. So, oh, this doesn't change my exit pressure very much. See, now I'm a little bit confused because it said it should be closer, the exit pressure should be close to the air pressure, but I could get it closer, but it didn't want me to get it closer. But you can see our thrust to weight ratio is now positive. So I guess that's kind of our goal, isn't it? All right, that's a huge improvement in Delta V. Oh yeah, I forgot that Delta V was also the other thing we had to look at. There's so many things to look at. Now let's take a look at the third stage. Okay, wait, there's another, oh. There's another engine. The third stage engine will mostly be working in the upper atmosphere. That's why my rocket had too many stages. I was supposed to combine the engines into the previous stages rather than having them be a separate stage. I could have created a 3-stage rocket that was actually 3 separate segments. I just didn't know what I was doing yet. The third stage engine will mostly be working in the upper atmosphere and in space. Cool. Change the altitude to vacuum. There we go. The Delta V is pretty good for this stage. We can improve it by lengthening the nozzle. Okay. Ideally, exit pressure would be 0 for a rocket engine designed to work in space. How is it even possible? But that would require an infinitely large nozzle. So there's my answer. Change the size to 35%. Hold on, let me see what's changing here. Thrust is going down. Delta V goes up. Oh, you know why Delta V goes up? Because this increases our burn time. And once we're in a vacuum, away from the effects of gravity and air resistance, increasing the burn time will keep increasing our velocity. It's all starting to make sense. I feel like I've just learned another language with this menu here. Change the nozzle to 160. All right, well, our Delta V is 3 kilometers a second, which is even, that beats our quest that we're going for, our mission. Now the rocket is ready for launch. I am so excited for this one. First stage, activate. Oh my goodness. Press space to activate your second stage. Remember to throttle up this time. Oh yeah. This is a different type of engine. It's not a solid motor anymore. Press and hold left shift to throttle up to 100%. Oh, here we go. Click and drag anywhere on the blue nav circle until your pitch is set to 70 degrees. Just line up the blue triangle with the flashing yellow triangle. Oh, whoops. Now click and drag anywhere. Wait, so why is it, am I supposed to know this on my own at some point until it's 90 degrees east? There we go. Your rocket will now start tilting. This is important because to be in orbit, you need to go sideways very fast. Yep, makes sense. All right, let me increase. Oh, I cannot fast forward right now. That's because I think it's adjusting its heading. Okay, so now we have locked into this new heading. Click the lock velocity prograde button on the right to lock your heading on your prograde. I don't know what prograde means. Lock velocity prograde. You can build your rocket to follow a natural gravity turn. This forces the rocket to pitch down as it goes up, following an efficient path to orbit without the need of complex guidance systems. Is that what I just did? Lock velocity prograde. Lock velocity retrograde. Oh, so prograde must be the opposite of retrograde. I never actually heard the word prograde before, but I've heard the word retrograde before. Wait until the fuel in this stage is depleted. I still cannot fast forward. So I think it is now automatically tilting itself to an ideal orbit trajectory. Press space to activate our third stage. Third time is a charm. There we go. Almost there. Burn your engine until your apoapsis passes 100 kilometers. Apoapsis is the highest point in your trajectory. Then what do? I guess it'll tell me once I get there, huh? This is kind of nerve-wracking. Like, there's so much stuff going on that has to happen at certain times, and the game's doing a good job at guiding me through it, but like, I don't feel ready for it. Press the X key to kill your throttle immediately. I want to do that right now. Okay. You can speed up the time and reduce waiting times. Wait until you're out of the atmosphere to increase game speed. So, how would I have known otherwise to kill my throttle at that point? All right, I've just reached the edge of the atmosphere at 80,000 meters. Click and drag anywhere on the blue nav circle until your pitch is set to 10 degrees. Click and drag anywhere on the orange circle until your heading is set to 95 degrees. Press the P key to unpause and continue. All right, how would I know that though? How would I know that's what I have to do? Select time warp to really speed things up. Pew! All right, there we go. Your final maneuver can be performed more efficiently closer. Oh, I didn't have enough time. Why'd you make me time warp if not give me time to read? Press and hold left shift to throttle up to 100%. At last, you need to raise your periapsis, the lowest point in the orbit, until it is higher than the atmosphere. This way you won't touch it at any moment, keeping you in orbit. How do I do that? I need to raise my periapsis. Is that like a setting somewhere? Do I have like orbit? Oh, here we go. Apoapsis. How do I pronounce that?
Apoapsis.
I completed light speed. All right, that's good. We need a periapsis of 80 kilometers. You need to go faster than 35 meters a second in order to get to orbital speeds at this height. You are almost there. Oh, I'm just waiting for my speed to get up to a certain level. Because yeah, my periapsis has to be 80 kilometers, which is the edge of the atmosphere. So I'm still above the edge of the atmosphere. I guess right now, yeah, it's happening. It's happening. It just happened? I have achieved my first orbit, and I'm just about to run out of fuel. That was like perfect. All right, my periapsis is 89 kilometers, and my, whoa, 585 kilometers. So at the speed I'm going right now, if I'm understanding this correctly, which I don't know if I am, I believe that as I orbit around Earth right now, I am going to fluctuate between 89 kilometers above the surface at its minimum, and then all the way out to 585 kilometers. And it's just gonna be kind of like that, it's gonna be like an oval type orbit. Wait, don't I have a map that I can look at my orbits? There we go, toggle map view. It's my orbit. There we go. See, all right, so this must be 89. Yeah, and then you can see the other apsis over on the other side with the green arrow. We completed a full orbit. We're orbiting. This actually might be getting us some tech points, some milestones, because we had to have like different altitude records and things like that. This is so cool. Save flight. So now, if I save and exit, Does that mean that this craft is gonna remain in orbit? As like, just because there was a part in the tech tree that, look, I have 70 tech points now. I have 1 point, I'm a millionaire. I just became a millionaire by launching this epic rocket into space. Okay, hold on. Before we go to the tech tree, let's look at our career right now. 900,000 to go 3 kilometers a second. I kind of just did that. $1 million? You're gonna give me $1 million? See, but here's the thing. How could I possibly get to orbit without the tutorial guiding me on when to do all of those things? Like how? How would that happen? Oh, wow. This is complex because now, whoa, this wants me to get into an orbit where there is a 2 kilometer difference between the maximum and minimum height of my orbit. That last orbit I had hundreds, had like a almost 500 kilometer distance between the two. All right, $1 million if I can do this. I need to bring some satellites into orbit. Let's start with something easy. None of this is easy without a tutorial to tell me every single step to do. Can you put this CubeSat into any orbit? I've already added a deployer in it to ease the integration, but you have to figure out where to put it in the rocket. So I have to launch something in orbit. All right, well, I mean, I might as well just accept everything, right? Okay, oh, look at this, resume flight. I can totally resume that orbit. Well, things just got way more complicated very, very quickly. I don't even know if I'm gonna be able to do any of these new missions like without my hand isn't going to be held anymore, so I don't know what's going to happen next time. So make sure you're subscribed so you don't miss that. This is getting kind of crazy. If you enjoyed this episode, you probably enjoy some more that you can find right here on the end screen. Hope this video has earned your subscription. Anyway, this has been ScrapMan, and I'll see you next time. Bye.